I'm going to continue this one from the last video actually. I have explained this till now. Rational means it is actually of the format of P by Q, and when you convert that one into the decimal format, it will be of either a terminating or a non-terminating recurring decimal expansion. But without undergoing division, we can find out what type of decimal expansion it is. Okay, there is a theorem for you. I'm not going to give the statement, just the meaning of the theorem. Okay, so the theorem says like this: if a number is given for you in the format of p by q, okay, let us say a number is given in the format of p by q, so then immediately you need to write on the prime factorization of the number q. So write out the prime factorization of this number. Okay, you can write on. Okay, so then if it is of the form 2 power m into 5 power n, where m comma n are actually what, non-negative integers, means they can take values 0, 1, 2, 3 and so on, then this number will have terminating decimal expansion. Okay, so definitely it will have terminating decimal expansion. Remember, okay, this is terminating decimal expansion whenever the decimal expansion of the denominator is of the form 2 power m into 5 power n. And I told for you p by q, this should be in the format of p by q, so that p and q should be co-prime, means there is no further divisor for both p and q. If there is any further divisor after writing the prime factorization, you need to divide, then only you need to verify this one whether it is in the format of 2 power m into 5 power n or not. Means now look at here, 0 is also included. So let us suppose if the denominator appears like this, 2 power 3 into 5 power 0, then it is also in the format of 2 power m into 5 power n. Means just if you write on the prime factorization of q, you will get just 2 power 3, but you will not get any powers of 5. Then you can write on 5 power 0, because 5 power 0 is actually 1. So if the prime factorization of the denominator appears in this format, then we can accept it is in the format of 2 power m into 5 power n by considering the exponent of 5 as 0. But sometimes you will get like this. Okay, just you will get like this 5 power 2 prime factorization of the denominator, you will get 5 power 2. You can imagine here 2 power 0 is present. Okay, then again this is also in the format of what, 2 power m into 5 power n, remember. So that's why by this one we can understand, when you express the denominator, as a product of primes, it may contain either 2. Okay, means either 2 means only 2, just 2, or uh, what, or 5. Okay, only 5, or both 2 and 5, 2 and 5. So then in all these cases, okay, so the terminating the decimal expansion of that number should be of the form of terminating. Okay, remember this one. In all other cases, okay, in all other cases means what, 2 along with any number other than 5, or 5 along with any other number other than 2, and 2 and 5 along with other numbers. Okay, 3, 7, 11, like that. Okay, prime numbers. In all these cases, the decimal expansion of that number will become what, non-terminating. Remember this one, this is the main concept in the last topic. Okay, non-terminating recurring actually. Okay, non-terminating recurring, this is the main content of the last topic. uh, and also you can decide by just a prime factorization of the denominator. And also I told for you, be careful about that one whenever it is given like this. Okay, so 9 divided by, let us suppose it is given like this, 9 divided by uh, a number is given to you, 9 divided by 24. Okay, now look at it, 9 divided by 24, but it is actually not in the format of p by q. So this is because you can divide 9 and 24 further actually. How can you divide? 3 3s are 9, 3 8s are 24. So this is actually what 3 by 8 actually. Okay, so if you verify the theorem for this one, it will become 3 divided by 2 power 3, and the denominator is in the form of 2 power m into 5 power n. So therefore it is actually what terminating. But you should be very careful about terminating. Okay, but you should be very careful about in this situation. Sometimes you will give the number like this, which is actually not in the format of p by q. It's looking like a p by q, but if there are any further divisors, you need to divide that one, then it will reduce us to the p by q format. Or else if you want to do like this, 9 by 24, 9 divided by, so if you factorize 24, you will get like this: 2 ones are 2 twos are, and then 2 six are, and then 2 threes are. So that's why what is the prime factorization of 24? 2 power 3 into 3 power 1. So but immediately you can decide, you are going to decide, so many students like that it is not in the format of 2 power m into 5 power n, that's why it is not terminating, but it is actually wrong. Remember, if it is possible to divide the numerator by any number in the denominator, you need to divide, then only you need to apply this theorem. Now look at here, 3 power 1 means it is 3 ones, and then it will go 3 threes, now it will become what, 3 divided by 2 power 3. Now according to this theorem, now it is in 2 power m into 5 power n, so that's why it is actually what, terminating. So just you need to remember this case. Okay, whenever so after expressing the denominator in the format of that is prime factorization, product of prime factorization, just look at the numerator. If it is divisible by any of the prime number which lies in the denominator, divide first, and then you, after that only, you need to verify this one. Okay, so whether it is in the format of 2 power m into 5 power n or it is not. Okay, if it is in the format of 2 power m into 5 power n, it is of the terminating format. If it is not in the format of 2 power m into 5 power n, means along with the 2 any other number appears, 3 7 like that. Okay, so along with 5, if there appears any other number other than 2, okay, like that 3 7 11, or else if 2 and 5 both appears, but along with the 2 and 5, if any other number appears, 7 11, okay, 13 19 like that, then those numbers will have what, non-terminating decimal expansion. Okay, so I think this much of knowledge will be enough for you for the first chapter. I have given the important concepts of this chapter. If you go through the problems, then you can understand further. And I have not shown any problems here, but you can understand. If you know this concept, you can understand the problems also. Okay, so now this completes the revision of the first chapter, real numbers. In the next class, I will move on to the second chapter, that is polynomials. Thank you, Ananda.